All right, so the first big thing that we talk about, and we're going to talk about, is equations. Solving a whole bunch of different types of equations. And then this lesson is in the appendix of the book. So when you get your book, it'd be at the very, very back. But it doesn't really matter. But anyway, that's why it's called lesson A.5 instead of unit 1 or whatever. It's kind of like the unit A. All right, so the first types of equations that we're going to solve are going to be quadratic equations. So what makes something a quadratic equation? X squared. So the largest exponent on a variable is going to be 2. So the standard form of a quadratic equation is ax squared plus bx plus c equals 0. So you do have to have an equals sign for it to be an equation, and you have to have the x squared term. But if it's missing the bx term, that's fine. If it's missing the constant term, that's also fine. Okay, so we're going to learn 4 methods for solving quadratic equations, and you might wonder why you have to learn so many ways. It's because sometimes the methods don't work. My favorite way to solve is factoring, but not every quadratic equation is going to factor. So we have to learn a bunch of different ways. So today we're going to do factoring and extracting square roots, and then Monday we'll talk about completing the square and the quadratic formula. All right, so for factoring, this first one we have has 2 terms, which makes it a little different than traditional factoring, and they're actually special terms. So do you guys remember what it's called when you have a situation like 25x squared minus 4, what that special factoring is called? Say it again. Right, they're perfect squares. So when there's 2 of them and there's subtraction in between, it's called difference of 2 squares. And if you don't remember what it's called, you probably do remember how to do it. Or if not, you will when you see it. So if you have 2 perfect squares that you're wanting to factor and there's subtraction between, there's a little shortcut method that we use where you find the square root of 25x squared. What is that? 5x. So it goes in each set of parentheses. And then you find the square root of 4. Good. And then what about the signs? One's a plus and one's a minus. So you probably remember that. So that takes care of the factoring part, but we still need to figure out what value for x we can put in, square it, multiply it by 25, subtract 4 from it, and get 0. So what do we do with those 2 factors? To figure out what x equals. Right, we're going to set each of those equal to 0 because you're multiplying those factors together. And if you multiply and get 0, that means one of them has to be 0. The only way you can multiply and get 0 is if you're multiplying by 0. So one of those is 0, so you set them equal to 0. And then you just have a 2-step equation to solve. And we get 2 solutions. And the majority of the quadratic equations you're going to solve are going to have 2 solutions. There are special cases when you have 1, so don't freak out if you only have 1 solution. I know there's one on your assignment that there's just 1 solution, but the majority of the time there's 2 numbers you can put in to get the answer. Okay, let's look at the next one. This one only has 2 terms. We're missing the constant term on this one, but we're still going to factor it. These are not squares. And it's not a difference. So we're not going to use what we just did. What are we going to do? Say it again. I think you were right. I just couldn't hear it. What are we going to do? Yes. We're going to factor out a common factor. All right, and I heard x. Is there something else that they have in common? 2. So we're going to factor out a 2x. So to factor out a common factor, you put it outside of the parentheses, and then you do the reverse of distributive properties. So distributing, you're multiplying. When you're factoring out a common factor, you divide. So we divide each of those by 2x, and we end up with 3x plus 4. Okay, then same thing like the last one. We're going to set each factor equal to 0. And we're going to get two answers, 0 and negative 4/3. So those two values for x that we can plug in and get a true statement, we would get 0 equals 0. Okay, we have one more, and it's got a lot going on. Like, this is a kind of a big step up from the last one that we did. So we have a little bit of an issue at the beginning, because to be able to solve by factoring, you need everything on one side. So the first thing, you need it in standard form. So the first thing you're going to do is get all terms on one side. We want it in standard form. Okay, so what else is kind of weird about this problem? Yeah. You technically can factor it with the fraction in there, but I would never want to do that. That would be super annoying. So because it's an equation, we can multiply through by a number to get rid of the fraction. What would we multiply by? Well, okay, so 3/2 would get rid of this fraction, but then it would make this one a fraction, because you'd get 15/2. So you don't have to multiply by a fraction. You can just multiply by a number that would get rid of the denominator. 3. So let's just multiply 3 by 3. So what do you get when you multiply 2/3 by 3? 2. Nice job. All right. So now we're left with a more normal looking trinomial. And when you're factoring a trinomial, you're going to do 2 parentheses. And what I end up putting here and here needs to multiply to give me 2x squared. So what do y'all think? 2x and an x. Good. Okay. And then the next thing I like to do on a trinomial is figure out my signs. So to know what your signs are, you look at this last sign. If it is addition, that means the signs inside your parentheses are the same. How do you know what they are? You look at the other one. So this plus sign tells you that these signs in here are going to be the same. And then this one tells you what they are. Okay. And then for the last one, what we put here and here need to multiply to give you 18. And then where's the 15x going to come in? It should what? Right, so we would have to multiply 2x by whatever we put there, multiply x by whatever you put there, and then when you add those together, you get 15x. Good. Now, if you don't figure it out real quick, just keep trying numbers until you get what works. So we could use 1 and 18, 2 and 9, or 3 and 6. So there's only 3 possibilities. Another thing that might help you save time if there's a lot of choices, you cannot have common factors inside your set of parentheses. So for example, if I wanted to try 3 and 6, I would not put the 6 with the 2 because they have a common factor. All right, I wouldn't put the 2 with the 2 or the 18 with the 2. So I would put the 3 with the 2 because they don't have a common factor. The 6 over there to get 18. And then 2 times 6 is going to give you 12. And then 3 plus 12 gives you the 15x that you were looking for. So that's how I like to factor. I don't ever teach the X method or any kind of method to factoring because I just want you, because people don't remember it. And I want you just to, I think it's easier for you if you just figure it out instead of trying to remember a method to do every time. Okay, so we're not done. We'll take each one of these factors and set them equal to 0. And we get 2 answers. I want you eventually to be able to look at your factors and just tell me what the solutions are without doing that whole process. So can you look at a factor of x plus 6 and tell me it's just going to be negative 6? Now, how is the other one different? Yeah. So if there is a coefficient in front of the x, you just put that on the bottom of the fraction. So same thing here. I want you eventually to be able to look at 3x plus 4 and know the solution is negative 4 over 3. Because you do the opposite and then divide by the coefficient. Now, if it takes a while to get there, it's fine. But that'll save you some time later. All right, let's talk about extracting square roots. This one is the easiest out of all of them, for sure. But you can rarely do it, is the problem. So on the 3 we just did, the only one we could solve by extracting square roots was the first one. So to solve by extracting square roots, you cannot have x squared and x. So any equation that has x squared and x, you can just go ahead and say, I can't do this by taking square roots, so we'll have to find another method. But extracting square roots is the most instinctual way to solve. You guys have been solving equations, I don't know, probably since 6th grade or something, maybe before then. And so you kind of know what you're doing. You want to solve for x. You want to get x by itself. And so that's why extracting square roots is a little easier because it's you have a plan, a goal to get to. So if you guys were doing D on your own, what would y'all do first to get x by itself? The first thing you want to do is divide by 3. So the 3 is not being squared. So a lot of people want to do the square root first. That's just going to make it kind of weird with the 3. So the first thing we want to do is isolate the squared term. So in this case, it's going to be dividing by 3. Then we're going to do the square root of both sides. So to get rid of a square, you take the square root. Now, one thing that you'll hear me say over and over and over is when you are solving an equation by taking the square root, you have to take the positive and negative square root. So because there are always not always, because there's 0, but almost always, there's 2 numbers that you can square to get the other one, a positive version and a negative version. So we do the positive and negative. All right, so we need to reduce or simplify the square root of 12. Now, you guys did this yesterday, so I'm going to have you all do that on your own. So we get two answers. 2 square root of 3 and negative 2 square root of 3. Two numbers I can square, multiply by 3, and get 36. All right, any questions? Okay, so let's look at E. Now E is a little different. Your term that's being squared is k minus 2, and that's already isolated. So we're ready to go ahead and take the square root of both sides. So the square root gets rid of the square, and we're just left with k minus 2 equals the positive and negative square root of 10. Now, can we simplify the square root of 10 like we just did the square root of 12? No, the only square that goes into 10 is 1, and 1 is kind of useless for reducing radicals. So we're done with that. So what do you think the last thing we do is? Right. Now, can you add 2 in the square root of 10 and get the square root of 12 or anything? No. So I like to stick it in the front. It's not wrong if you put it behind the 10, as long as you don't add them together, like actually add them. For some reason, I just like the way that looks better with it in front of the plus or minus. So that's two answers, 2 plus the square root of 10 and 2 minus the square root of 10. All right, I'm going to have you guys try F on your own. It's slightly tricky, not too bad though. So it's a little different than the one we just did, because the one we just did, you had a radical where we couldn't combine them, but we can add 2 and 1 and get 3. And we can add negative 2 and 1 and get negative 1. So you want to go ahead and do that if you can combine them. And then just divide by the 2, so you get 2 answers, 3 halves and negative 1 half. All right, I want to talk to you guys for a second about that equations worksheet I gave you on the first day. It's going to be due on Monday, and I do want you to turn it in Classroom. So take a picture of it or scan it and turn it in Classroom. But I want you to know that if you don't get the very last one done, then it's fine. I talked to Ms. Stewart yesterday, and she said that you guys never did that you were supposed to do it, and it snowed, and then it got pushed back, and then you just never did it. So that last one, don't worry about it. Are there any others that you feel like you just need like a little hint to get you going? You can get it out if you want to. I told you I'd give you hints each day, and then I didn't do that yesterday. So I think there's like 3 of them on there that is either factoring or solving by taking square roots. So those 3 might be in good shape. But the very last one, the rational equation, I don't think you've ever done it. But I'll teach it to you soon, actually. Any questions on those? Okay. All right. So I'm going to go ahead and give you your assignment. Now, it's called page A56, but for you guys, Yeah, for you guys, it's just that page that I gave you. I want you to do 25, 26 through 40 even, and then 41 and 42. Please don't try to do them on that sheet. Do them on a separate sheet. Now, I have some paper that's right over there that someone in my last class didn't have any. So if you need to grab some paper, you can. It's fine with me. $25 and then 26 through 40 even. And then 41 and 42.